Forget everything you thought you knew about electric cars. Tesla's not just planning cheaper batteries, they're planning to end lithium forever. And the shocking part, the game-changing $1,795 aluminum-ion battery is already real and coming for the 2026 Tesla Model 2. Could this finally make EVs as affordable as a used Corolla while crushing every rival automaker in the process? Let's break down how Elon Musk's secret plan might flip the entire car industry on its head. Asterisk, every Tesla, every EV you've seen so far, they're all about to become museum pieces. Because Elon Musk just threw down a gauntlet to the entire battery industry with 3 words that will haunt lithium miners forever. End of lithium. That's Musk dropping a nuclear bomb called an aluminum-ion battery, and it's already planned for the 2026 Tesla Model 2. While the world worried about charging stations and range anxiety, Musk was quietly plotting the complete overthrow of everything you thought you knew about EV batteries. My guess is people are going to start hitting challenges with power generation by the middle or end of next year. Musk wasn't just talking about power shortages, he was hinting at the hard truth that lithium itself is running out of road. That's where Tesla's aluminum-ion battery comes in, promising a revolutionary price of just $1,795. But how can Tesla build something so powerful, yet so cheap? And could this breakthrough finally make EVs truly affordable for everyone? In this video, you'll uncover how Tesla plans to build the revolutionary $1,795 aluminum-ion battery for the 2026 Model 2 and why it could destroy the lithium industry forever. From secret prototype testing to game-changing dry electrode tech, we reveal how Tesla might make EVs cheaper than ever imagined. If you're ready to see how this could flip the auto world overnight, join over 157,759 subscribers by smashing that subscribe button and turning on the bell for Road Zone reviews. Asterisk now, how realistic is a $1,795 Tesla aluminum-ion battery pack? At first glance, it might sound like futuristic hype, but when you dig deeper into the science, global supply chains, and Tesla's vertically integrated manufacturing, it starts to look not just possible, but almost inevitable. This price isn't some random target plucked out of thin air. It's the product of years of relentless R&D, secret collaborations, and bold engineering strategies that other automakers haven't dared to attempt. Behind the scenes, Tesla has been quietly developing something they call aerosol fusion in partnership with the University of Texas, and this isn't just an experiment in a hidden lab. While lithium miners battle over shrinking supplies in remote deserts, aluminum remains the third most abundant element in Earth's crust. Picture this: aluminum costs around $2,000 per ton, compared to lithium's projected $15,000 per ton by 2025, giving Tesla a massive 7 to 12x cost advantage before production even starts. When combined with Tesla's dry electrode tech and in-house cell production, that's how a $1,795 battery stops being a dream and becomes the spark that could revolutionize electric vehicles forever. And remember when Tesla acquired Maxwell Technologies in 2019, it wasn't just another deal, it was Tesla locking in its future through dry electrode manufacturing. Traditional lithium-ion production eats up energy with wet paste coatings, while Tesla's dry process cuts energy use by 70% in factory space in half. Tesla's California pilot plant has been refining this method, delivering massive cost savings. When combined with aluminum's natural abundance, lithium batteries start to look like overpriced antiques. Tesla's vertical integration is where it really gets scary for competitors. While Ford and GM still rely on suppliers and pay premium prices, Tesla does it all from raw material sourcing to cell production, wiping out middlemen and vulnerabilities that choke rival margins. Tesla's Gigafactory network from Fremont to Berlin to Shanghai and Texas forms the planet's most advanced battery production web, and by 2026 these factories will be producing 4,680 cells at scale, with aluminum-ion batteries riding the same infrastructure, cutting costs by roughly 30% compared to lithium-ion. So let's really break down the numbers behind Tesla's shocking $1,795 aluminum-ion battery. Roughly $1,000 goes into raw materials and production, $500 covers years of R&D amortization, and $295 becomes Tesla's profit margin. Sounds unbelievable? Think again. Tesla has a proven track record of blowing up price barriers. They've already slashed Model 3 prices by about 20% since 2017, thanks to vertical integration and bold manufacturing advances. Now, imagine this: a 60 kilowatt-hours aluminum-ion battery pack coming in at around $30 per kilowatt-hour. Compare that to today's lithium-ion batteries, which cost anywhere from $100 to $150 per kilowatt-hour. That's not just a cost reduction, that's market obliteration. Tesla wouldn't just undercut the competition, they'd leave them scrambling to catch up in a race that's already over before it starts. But what makes this even more terrifying for competitors is Tesla's speed to market. Aluminum is vastly easier to source than lithium, no complex extraction, no fragile supply chains, and it's globally abundant. Plus, Tesla's existing aluminum casting processes, already used to make vehicle frames, line up perfectly with aluminum-ion battery production. While other automakers are still battling supply bottlenecks and praying for lithium contracts, Tesla is quietly laying the groundwork for total market domination. Still, the big question remains, how close are we really? Is this aluminum-ion battery still stuck in lab prototypes, or is it already rolling toward mass production in the 2026 Tesla Model 2? Let's dive into what's really happening behind Tesla's closed doors. Behind Tesla's closed doors, things look electrifying. Unconfirmed reports say Tesla is building 100 to 200 aluminum-ion prototype cells per day. This isn't just testing its preparation for mass production. Their KO factory in California leads R&D, while Giga Nevada handles real-world trials. Tesla also partnered with the University of Queensland, known for aluminum-ion breakthroughs. This collaboration marries academic research with Tesla's manufacturing muscle. Early tests show aluminum-ion batteries retaining 99% capacity after 10,000 charge cycles, while lithium-ion degrades after 1,000 to 2,000 cycles. Tesla's tweaks, like adding fluethylene carbonate for electrode stability, fix the moisture issues that previously blocked aluminum-ion from going mainstream. Of course, scaling production remains challenging. Solid-state electrolyte synthesis and early cathode loss rates echo Tesla's past struggles with 4,680 cells. Yet Tesla's track record of turning setbacks into breakthroughs, like boosting for 680 output to 500,000 cells daily, proves they don't just face problems, they solve them at a scale no rival has matched. Tesla plans to unveil the Model 2 in late 2025, with production in 2026 at Fremont, Shanghai, Berlin, Texas, and a New Mexico plant. Insiders say aluminum-ion packs could first appear in select Model 2 trims in 2026, then fully roll out by 2027. And rumor has it, these packs could give the Model 2 up to 600 miles of range-destroying range anxiety without destroying your wallet. Now, why could Tesla's aluminum-ion batteries spark a global energy revolution? Imagine a future where batteries aren't built only in gigafactories but also in small, flexible microfactories near local demand. Thanks to aluminum's simple chemistry and abundance, Tesla could decentralize production, cut logistics costs by 40%, and bring EVs even to regions once thought impossible. And aluminum-ion batteries laugh at extreme climates. A 2024 University of Queensland study proved they perform flawlessly from -40 degrees Celsius to +80 degrees Celsius. Unlike lithium batteries that lose power in harsh conditions, aluminum-ion tech keeps EVs running strong through icy Siberian winters or scorching Sahara heat, unlocking markets once thought impossible. But Tesla may be thinking even bigger. Rumors link Tesla's aluminum-ion project to space, potentially making the Model 2 a testbed for batteries that could power lunar rovers or satellites. Aluminum-ion's lightweight design and stability, backed by 2024 research, make it ideal for space applications where every gram counts. And here's the truly radical part. Tesla's modular aluminum-ion chemistry could let drivers customize their battery's power output, from 50 to 200 watt-hours per kilogram. Imagine walking into a Tesla showroom and picking a pack built just for your lifestyle, whether it's daily city commutes, epic cross-country road trips, or rugged commercial use, all while keeping the same affordable price. Finally, these batteries could help power entire communities. A fleet of Model 2 South, each with a 60 kilowatt-hours pack, could act as mobile energy nodes for disaster relief or rural microgrids, turning cars into moving power stations. This isn't just the end of lithium, it's the spark of a bold new energy era. That $1,795 battery isn't just a number. It's a challenge, daring every automaker and energy giant to rewrite what's possible. We're not just witnessing history, we're driving headfirst into a future that could make EVs affordable for all. Want to stay ahead as this revolution unfolds? Smash that like, subscribe, and keep rolling with Road Zone Reviews.